Hey guys, so we are going to be covering still lesson 9.5, but we're going to focus on one piece of the quadratic formula, and that piece is called the discriminant. So we're going to talk about it and how it can help you. Okay, and so let's discuss what is the discriminant. So these should be pretty short notes, and as we talked about during the week, this will be the last set of notes for the year, unless Mr. Johnson and I get a bug and we decide to do something else. So the discriminant is actually the radicand of the quadratic formula. And that would be b squared minus 4ac. Now you might say, okay, that's awesome, great. Why do they call it that? What is its purpose? And its value reveals how many times the parabola, can you hear somebody's having a party in my neighborhood? The parabola crosses the x-axis. Okay, so these are called the x-intercepts. They're called the solutions. They're called the roots. I'm trying to think if there's anything else we used to call it. Yeah, I would say that's good enough. Okay, so that's what the whole point behind solving quadratic formulas is to figure out where they cross, but the discriminant can tell you how it crosses. Why is that important? Because it lets you know if your parabola is floating above, it doesn't cross at all. If it just touches once, its vertex, that means you only have one solution, trinomial square. And then guess what you get when it's a trinomial square? And then we have, if there's two, that means it just crosses the parabola two locations. So it's kind of a traditional parabola. All right, so I'm going to draw a little chart here. And we're going to look at an equation. And then we're going to look at x squared plus 2x plus 5 equals 0. We're going to look at x squared plus 10x plus 25 equals 0. And then 2x squared minus 7x plus 2 equals 0. And I may need to extend my lines here. So we're going to look at the discriminant first. Okay, and we're going to calculate that out, and we're going to remember that that's going to be b squared minus 4ac. We're going to look at the numbers, we're going to graph it, and then we're going to determine the number of roots. And then we'll do a couple practice problems, and that'll be it. In fact, I'm going to extend these lines all the way down. So we're going to do discriminant on these. Then we're going to graph. And then we're going to do the number of roots. And roots is another way of saying x-intercepts. We're going to call it real roots. Okay, so those have to be numbers in the real number system. All right, so let's start. All of our equations are written in standard form, so we can easily identify A is 1, B is 2, C is 5 in the first one. So then what we're going to do is we're going to take those numbers and plug them into b squared minus 4ac, the discriminant, the part that's underneath the radical sign. So we're going to get 2 squared minus 4 times 1 times 5, and that's going to give us 4 minus 20 which gives us a negative 16. So let's go ahead and graph this. So if we know the axis of symmetry on this one would be negative b over 2a would be negative 2 over 2, which would give us a negative 1. So we're going to have a vertex of negative 1. We put that back into the formula. So we get 1 minus 2 is going to be negative 1 plus 5 equals 4. So we're going to be at negative 1, 4. And then, so we'll kind of branch out from there. So let's see, negative 1, 4. I'm going to make this go down real low. So x, y, boom, boom, boom. Okay, so let's see. If I did negative 1, 4. Oh, let me put some numbers here. I didn't do that yet. 2, 4, 6, 8. So negative 1, 4 would be about here. If I put in 0, I get out 5, which means if I put in negative 2, I get out 5. If I put in 1, I'm going to get 1 plus 2 is 3. 3 plus 5 is 8. So 1, 8. And negative 3 would also be 8. And then I graph it. So, how many solutions did I get? We got 0. So what are some conclusions that we can take? Let's look at what did we notice when we did the discriminant? It equaled a negative number. And then if it's negative, that means I'd be taking the square root of a negative number, which doesn't work. So we would say there's no real solutions. And we can see in the graph there's no real solutions because it's floating above the x-axis. And the reason for that would be the square root of negative 16. We can't do that. There's no solution. Okay? All right. Let's try the next one. We have A equals 1, B equals 10, and C equals 25. So then if we plug those in, we get, let's see, B squared, 10 squared minus 4 times A times C. That gives us 100 minus 100, which equals 0. All right, so let's think about this one. So my x value is going to be 1, or negative b over 2a, sorry, brain. Negative b over 2a. So negative 10 over 2 is going to give me negative 5. Plug that in, we're going to get 25 minus 50, that's negative 25, plus 25 is going to give me 0. So 25, no, that's not right. No, that is right. 25 and 25 is 50. So yeah, we get that. All right, so let me think about how that graph's going to look like. Boom, boom, boom. Boom, boom, boom. So let's put in some numbers. Okay, so my negative 5, 0, that's going to be my starting point. Let's see, so that's my vertex. So if I put in negative 4, that's going to give me 16 minus 40 plus 25. So 16 minus 40 is going to give me what? 24 and then 25. That's going to give me 1. So negative 4, 1. And negative 6 would also give me 1. And then negative 3, let's see, that's going to give me 9 minus 30 plus 25. So 9, 34, and then 30. So that's going to give me 4. 4, and also negative 7. Ooh, let me plug that guy in. Negative 7. And then we go up there, and then we sketch it out. It's not very beautiful, but you get the idea. So, how many roots did we get? Well, we got exactly 1. And in this particular problem, we got the discriminant was equal to 0. There is 1 real solution. And what we ended up with is the square root of 0 equals 0. And the number ends up being, let's see, 0 equals negative b over 2a. Okay, so did I do that right? Let me think. If I put in 0, I would get out 25. Wow, that would go way the heck up there, wouldn't it? Yeah. So, and the reason why it says x equals negative 2 b over 2a, remember, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So you have 0 under the radical sign. That's going to give you x equals negative b over 2a, which is going to give you the axis of symmetry, which is the x-coordinate of the vertex. Okay, so that's what this guy leads to, is the vertex. Okay, so if you look back, that particular equation was a trinomial square. Hint, hint, we talked about that. All right, well, last one, you could probably already predict what we're going to get. A equals 0, b equals negative 7, c equals 2. So we plug those in, and we get negative 7 squared minus 4 times a times c. That's going to give me 49 minus, let's see, we got 16, and that's going to give us 33. So if I graph this, oh, there's my kitty cat saying hello. Let's see. If we did negative b over 2a, so that would be positive 7 over 4, which would be 7 over 4 would give us 1 and 3/4. Okay? Oops, sorry. Forgot to do that. Now this gets a little ugly when I'm trying to figure out the other guy. So I'm going to kind of do this off to the side just to calculate it out. So I'm going to have 2 times 7/4 squared minus 7 times 7/4 plus 2. So we're going to get 2 times 49/16 minus 49/4 plus 2. So here goes into that 8 times. So I'm going to multiply this guy top and bottom by 2, and I'm going to multiply this guy top and bottom by 8. So that gives me 49 minus 98 plus 16 all over 8. Excuse me, 8. So that's going to give me negative 49 plus 16 is going to give me a negative 33/8, which is going to give me a whopping negative, let's see, that's going to go in 4 times with 1/8 left over. Okay, so there we go. Oops, I'm having trouble writing tonight. All right, so let's see. let's do kind of like this. Now, this is an interesting one because my x-intercept is a fraction, picking numbers that are one to the right and one to the left is going to give me more mixed numbers and fractions to deal with. So sometimes it's easier if we just pick whole numbers, and my parabola will be a little bit askew, but it'll work, which means I'm not going to get what I get the answer for one is not going to be the answer of the other. So here's what I would do on this one. 1, 2, 3, 2, 4. We've got -2, -4. Then we'll go up to there. So let's see. So we get 1 3/4, -4 1/8. All right, let me get a color in here. I'd say that's about there. Okay, so I'm going to pick 2, 1 and 2. So 1 goes in, and 1's going to be 2 minus 7 is -5, plus 2 is going to be -3. So 1 and then -3. Now if I put 2 in there, it's going to be 4, 8, 8 minus 14, that's 6, plus 2 is 8. Let's see, is that right? 2, 4, 8 minus 14 is, oh, -6, plus 2 is -4. So notice it's not quite what we're hoping for. All right, let's try 0. That's going to give me a +2. Ooh, that's nice. Way up here. And then if I try 3, let's say I get 9 times 2 is 18, minus 21, that's -3, plus 2 is going to give me -1. So if we sketch it out, it's going to look something like this. So we are going to get 2 places where it crosses the x-axis. Now my graph is not very accurate there, but you know what I mean. So we can draw a conclusion from it though, right? How many solutions? How many real roots? 2. And we found that the discriminant was equal to a positive number. So then we ended up getting 2 real root solutions, or 2 real solutions, I should say. And we're just going to get the square root of a positive number. Okay, so I'm not even going to draw that on there. All right, so I'm going to go to my next screen, and we're going to do just a couple of examples. And the directions are going to ask us to find the discriminant value. And then determine, so it's actually not a lot of work. The number of real solutions of the equation. Okay, so number 1, we have 4x squared minus 5x equals -3. So job 1, we need to get it in standard form, so we're going to add 3 to both sides. That's going to give us 4x squared plus 5x plus 3 equals 0. Now we identify A, B, and C. So A is 1, B is 5, C is 3. And then we plug it into b squared minus 4ac. So b squared minus 4ac. So that gives us 5 squared minus 4 times 1 times 3. 25 minus 12 equals 13. So the first And, sorry, I did that wrong. Did I do that wrong? 25 minus 4. Oh, yeah, I did do something wrong. Let's try that again, shall we? Okay, Mr. Eraser, come out. Boop, 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 boom. There is my first mistake. 4 is the value of A. I got so used to having 1. Let's try this again, shall we? So then this is going to give us B squared minus 4 times A times C. So I get 25 minus 48, and that's going to give me a negative 23. So that's answer 1. Find the discriminant value. So that's the discriminant value. And then because it's negative, we would say there's no real solutions. In other words, you'd have a negative under the radical sign, and you'd have a floater, either facing upward and above, facing downward and below the x-axis. All right, let's try another one. So we've got 2x squared plus 15 plus 11x equals 0. So everything's on one side, 0's on the other. Unfortunately, the equation is not in standard form, so I'm going to need to rearrange it, because the b value is always what's associated with the linear term. All right, now I identify my a, b, and c. So a is 2, b is negative 11, c equals 15. So we put it into our formula. B squared minus 4 times a times c. So I get 121 minus 8 times 15. Let's see, actually let's do 4 times 30 is 120. And we get an answer of 1. Now 1 is positive. So if we have a positive discriminant, then that means there's 2 real solutions. So 2 answers there. All right, and last but not least, 9x squared minus 30x plus 25 equals 0. Everything is written exactly the way it's supposed to be. Let's identify A as 9, B is negative 30, and C is 25. Crazy big numbers. So substituting into the discriminant part, we have b squared minus 4 times a times c. So let's see. Negative squared is positive, 3 squared is 9, 0 squared is 2 zeros, so that's going to give me 900. And then we have minus, and then we have 4 times 25 is 100 times 9 is 900, and that gives me a difference of 0. Okay, so when it is 0, then we have one solution, one real solution, and that would actually be the vertex, because what we had was a trinomial square. So there you are. Good luck, guys. Bye now.